What do you mean by learning? Yes? Knowledge? What is that?
Getting the information or knowledge about anything, sir.
Getting information,
Knowledge, sir.
knowledge about anything, right? Once it is done, what you'll do it? What you'll do
Using
it?
it, utilizing the information for applications.
Oh, so what exactly happens in the learning process?
The learning process.
Learning ಮಾಡೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? You learn something. You learn something. Learning is something like an experience, right? It's an experience. Learning is something like an experience. Once you experience something, you apply it on the real world. Is it right? If I say something called as 4 multiplied by 3, what you will do is that 4 multiplied by 3 is equal to 12. It's an experience, right? We have learned it. If I say something called as 5 multiplied by 4, I'll say that I'll give some I learn it, right? That is my new experience that comes around 20, right? 5 multiplied by 4, it is nothing but 20. 4 multiplied by 3 is nothing but 12, and 6 multiplied by 3 is nothing but 18. That is all my learning. Now I'll give a new problem called as 7 multiplied by 8. 7 multiplied by 8, right? I have the experience, right? 4 multiplied by 3 is my experience, which has given the result as 12. 5 multiplied by 3, sorry, 5 multiplied by 4, I have an experience of getting the result as 20. 6 multiplied by, let us take 3, I have an experience of getting it as 18. So these are the learning experiences what I have it. So now I'll give a new problem called as 7 multiplied by 8, right? So what my previous knowledge has to do is that apply the previous knowledge or apply the previous learning and try to find a solution for the current problem. So what is my current problem? It is 7 multiplied by 8, which is nothing but 56. Are you getting my point? All of you? Are you there? ಇದ್ರೇನ್ರಿ?
Got understood.
Are you getting? ಏನ ಅರ್ಥ ಆಯ್ತಾ ನಾನು ಹೇಳುದು? ಅರ್ಥ ಆಗ್ತಿದೆಯಾ ನಾನು ಹೇಳುದು? Yes?
Yes, sir.
I have the experience. Pardon? I have given the experience, that is 4 multiplied by 3 is equal to 12. This is my first experience.
Yes, sir.
5 multiplied by 4 is second experience.
It is not
That
audible.
is 20. 6 multiplied by 3 is my third experience, which has given a result as 18. Is it right?
Yes, sir.
Now I want to apply the previous learning or my experience to derive the solution for the next problem called as 7 multiplied by 8. Is it right? This continuous process of learning the things, getting the experience, and solving the new problem is the foundation of the machine learning or the learning process. So what do you mean by machine learning? Here we are teaching the machine something, or we are giving the machine some experience so that it will, whenever it encounters a new problem, it is able to solve those new problem. That's why the name we have given it as the machine learning. We have called it as the machine learning, like you are human being, like us, all of us, the human beings. What you do is that we know the once you learn something, we apply that something to solve the new one. Is it right? That is my experience. The same thing is being done for the machines. So what I'm doing is that I'm teaching the machine something. I'm teaching machine something, and from the experience what it has got from the earlier or the previous learning, it will try to solve the new problems. The whole approach we call it as the machine learning. It is right, and here the machine doesn't come as its own what you call it as intelligence. Instead of that, what I'm doing is that I'm giving that intelligence through my logic, right? So and the whole process we generally call it as the machine learning. And the course objective, the objective of the course is that the course will enable the students to define machine learning and understand the basic theory underlying the machine learning. What do you mean by the machine learning, and what is the theory behind the machine learning, that we are trying to understand it. The differentiate between supervised, unsupervised, as well as the reinforced learning as well, right? So we try to differentiate between supervised, unsupervised, as well as the reinforced reinforcement learning, and understand the basic concept of learning and the decision trees, right? We are just trying to understand what you mean by the learning and the decision tree as well, and understand neural networks and Bayesian techniques for problems appear in the machine learning. These are the different techniques for solving the problems which are arising in the machine learning. Understand the instant based learning and the reinforced learning as well, right? Apart from the supervised and the unsupervised learning, we try to learn something called as the instant based learning as well as the reinforced learning as well. And the perform statistical analysis of machine learning techniques. We'll try to analyze different machine learning techniques based on some statistics. So we'll come out with which one is better one um, in terms of the performance and other the parameters as well. These are the objective of the machine learning courses. The first one, we'll try to learn what you mean by the machine learning, and what do you mean by the supervised, unsupervised, as well as the reinforcement learning as well. And also we'll try to learn the decision trees and Bayesian networks as Bayesian techniques and the neural networks. And also we'll try to understand instant based learning as well as the reinforced learning. And we'll try to assess, or we'll try to analyze different machine learning techniques based on some parameters, and we'll try to come out with the analysis part, that is stating which algorithms and which machine learning technique will give you the best performance. And these are the outcomes of the study. Objective in the sense that before starting the course, so these are the objective. The students can learn so and so. And outcome in the sense that after learning the things, what you'll get it. And after studying the course, the students will be able to choose the learning techniques and investigate concept learning, right? Once they have started with the learning this one, so they can investigate the other learning techniques called as the concept learning, and identify the characteristic of decision tree and solve problems associated with. So you can also identify the basic characteristic of the decision tree, and also you try to solve the problems associated with the decision tree, and apply effectively neural networks for the appropriate applications. Apply the neural networks for some applications, so that you'll get the solutions. And apply Bayesian techniques and derive effectively the learning rules using the Bayesian techniques. You try to effectively learn the rules, and evaluate hypothesis and investigate instant based learning and the reinforced learning, right? So apart from like you the all everything else, So you also try to learn hypothesis and investigate the instant based learning as well as the reinforced learning as well. The overall we in the entire course will try to learn the different learning process, that is supervised learning and unsupervised learning as well as reinforcement learning. And there are some machine learning techniques like the decision trees and the Bayesian networks and the neural networks, right? You'll try to learn all those things. And these are the reference books which we are talking about, that is Tom Mitchell and machine learning India edition 2013, Macro Hill Education. And the reference book Trevor Husty. And this is one textbook which which you're supposed to use it. And these are all the reference books. Addition to the textbook, you can also use the reference books. And to learn the machine learning, there are some prerequisites. The first one is the basic programming skills like Python, basically Python. Having C++, C language knowledge, and the C Java, it is fine. But having knowledge of the Python will be very essential to learn the machine learning course. And the algorithm design, you try to learn, or you should know how the algorithms will be built it. And basics of probability and statistics, this is one more important aspect of the things which you have learned, which you have learned it in the third semester, right? The probability and statistics, is it right? Can you answer me? Right, probability and statistics, you already learned it in third or fourth semester, which you already forgotten it, right? But try to go back to uh, math and math and try to refresh it once again. So that is the basics of the probability and statistics. You already familiar with these two. That is a basic programming skills, particularly in the Python, and the algorithm design which you have studied. So algorithm design you studied it in fourth semester, and basic programming skills in Python, which you have studied in the sixth semester. That is very much familiar. But as far as this one, the probability and statistics, which you have learned in third and fourth semester, but you already forgotten it, because these things has to be refreshed every very frequently, which you have not done, because we don't have computer. As a computer science students, you don't have much uh, things to learn from the probability and statistics. Now we go back to probability and statistics and refresh it once, right? And the content of the entire subject is something like this. It is organized into five modules, module 1 to module 5. Module 1 talks about introduction as well as the concept learning. What do you mean by the concept learning? And the module 2 talks about decision tree learning, and module 3 talks about artificial neural networks, and module 4 Bayesian learning, and module 5 talks about evaluating hypothesis, instance based learning, as well as a reinforcement learning. These are the five modules we are talking about. Module 1 introduction as well as the concept learning. And these are the very important one: decision tree learning, artificial neural network, Bayesian learning, as well as the hypothesis instance based learning, as well as the reinforcement learning. Let us begin the first module, which contains the introduction of the machine learning as well as the concept learning. Let us try to understand what basically formulated the machine learning and what leads to the machine learning. Ever since computers were invented, we have wondered whether they might be made to learn. If you could understand how to program them to learn to improve automatically with experience, the impact would be dramatic. So what you have learned is that up to now, what you have learned is that if you give some instruction to the computer, and your computer will be able to execute those instructions as far as the instruction is given, right? And they don't have they don't have the capability to think it. They don't have the ability to take the decision on their own. So the whole idea of the machine learning is to teach the machines in such a way that they should get some experience, and from that experience they are able to change, or they are able to what you call it as take the decision independently. That is exactly what the machine learning talks about. Ever since computers were invented, we have wondered whether they might be made to learn, right? We are thought that whether the computers has the ability to learn. If they are able to learn it, they can do many things. They can take the decisions independently. If you could understand how to program them to learn to improve automatically with experience, the impact would be dramatic. That if they are able to learn the things on their own, then you can change the uh, or you can get the experience. Imagine computers learning with medical records which treatments are most effective for new diseases. We have already some medicines for the existing what you call it as diseases. If a new case or a new diseases comes, if the machine is able to prescribe you some new medicines, right, based on the previous experience, then that will be very a good one. That is, imagine computers learning from medical records which treatments are most effective for the new diseases. Take for example of the COVID-19, right? So for COVID-19 there is no the effective medicines are still now available. There is no effective treatment is not available. If the machine is able to tell what medicines you're supposed to take it from its previous experience, like we had something called as a SARS disease, we have the influenza, we have the flu, right? Based on the, like, we have recorded everything that is the medicines for all those diseases, SARS and what you call it as a flu, or the whatever influenza, or all these diseases we have formulated it, and we have kept a record stating that these are the so and so treatments for the available diseases. And if a new disease comes, let us take the corona or the COVID-19, right? In that case, the machine should tell the person stating that this is my previous experience. This is my experience. From my previous experience, I can state that this is the new medicines, or this is the treatment for the COVID-19. That is what the states. That is, imagine computers learning from the medical records which treatments are most effective for the new diseases. That is very important. Houses learning from experience to optimize energy cost based on the particular usage patterns of their occupants. If the houses is able to record their previous experience, that is, let us take for example, uh, your machine has recorded the energy consumption from the last 1 year, right? If in the last 1 year you have consumed so and so, and if the machine is able to correctly predict the what you call it as the energy needs of the current month, then that will be very good one. And this also comes from the previous experience. That is, you have stored the records of the last previous 12 months records into your database, and from that 12-month record your machine is easily able to predict what is uh, the the energy, or the what is the energy consumption from the current month. And personal software assistants learning the evolving interest of their users in order to highlight especially relevant stories from the online morning newspaper, right? So your PDS or the PDA, what you call it as, right, is able to navigate, or it is able to tell you uh, what is the latest story from your last experiences, or the last your browsing experiences. So okay, you have browsed something in the last few sessions, and from your last few browsing sessions, whatever the experience your machine has got, from that one it can easily notify you what are the latest stories. Okay, so these are the few examples of what we call it as the machine learning techniques. That is, imagine computers learning from the medical records which treatments are most effective for the new diseases. right? From the earlier experience we can state that what is the experience or what is the treatment for the new disease, and also it can predict the optimize also optimal usage of the energy from the last records, like let us take 5 records or the 10 records or maybe 100 records. And also your PDS or the PSA, or you'll also be able to tell you what is the latest story from your last experiences. And examples of successful applications of the machine learning where the machine learning can be applied it, right? And the first one is learning to recognize the spoken words. This is very important. So so where the machine learning can be applied it, the first one, it is able to recognize the spoken words. Spoken words are very difficult to predict it because it also depends on the accent of the people, right? So how you pronounce a particular word in one area of the one region of the uh, country, the same word will be pronounced differently, right? In another part of the or in another region of the same country, it will be pronounced, or it will be pronounced something different, right? So recognizing all these words is very important, and that will be done by the machine learning. And learning to drive an autonomous vehicle, this is one area of the important area of the machine learning. That is, your your machine or the autonomous vehicle is able to take the decision on its own, or independent decision it is able to take it, because it has encountered, or it has from its earlier experiences, it can take its own decisions. It can take own decision, and this is done by the machine learning. And learning to classify new astronomical structures. So the astronomical structure in the sense how the comets will appear it, and how the different planets will show it, how the different what you call it as different objects within the solar system will look like. And that from that one you can easily classify. So what are the different astronomical structure? They, if a particular object appears like this, you classify into one group. And if the object looks something like this, you classify into one other one. And if you make it and you keep it here, you keep it into a database. When a new object comes, when a new object comes, your machine will look into its database, and it will predict what kind of object it is observing it, right? So that is called as the classification of the new astronomical structure. It will keep that one, uh, what you call it as, it will keep that new object into a particular classification. And learning to play a world class back game on, right? This is one game which is being used. And in this case, it's also being used, it's also making use of the machine learning. These are the some of the areas or the applications of the machine learning. And one two important this one is the autonomous vehicle and the astronomical structure. In this case, you're just making use of the machine learning very effectively, even with respect to playing the games as well as recognizing those spoken words. You are just making use of the machine learning. Okay, so in recognizing the spoken words, so you supposed to identify the accent of the different people, and you have to classify them. And in an autonomous vehicle, what you're doing is that you're just trying to drive an autonomous vehicle or a vehicle on its own, right? And it will record every incident or a new learning experience into its database. Whenever the same uh, incident happens, it will take the decision from its previous experience. That is called as the autonomous vehicle. What it is going to do it. Let us take, for example, if it encounters an what you call it as a pathway, what it will do is that in the previous experience, what it has learned is that you have to slow down the vehicle, right? Slowly drive it through the pathway, and at least you try to avoid the pathway. If at all not possible to avoid it pathway, you drive slowly and get into the pathway and pass it through the pathway. That is what uh, you have recorded it, and it will be stored into the database. If while driving it, if it encounters another pathway, then from the previous experience what it has learned, it as you try to avoid that pothole. Your autonomous vehicle do that. If it is not possible, what it will do is that from the previous learning or the previous experience what it has learned, it will get into the pathole and it will drive slowly through the pathole. That is exactly, you call it as a autonomous vehicle. And we, even with the astronomical structures, you can classify the different astronomical structures based on their appearance and based on their some characteristics, and group into some classify them into some groups, right? If a new object or a new structure appears uh, in the sky, so you have to classify, or you have to place that new structure into some category or some classifications. And even you can try to learn how to play the world class back game on, right? And why the machine learning is very important, that is the things here. Some tasks cannot be defined well except by uh, example. That is how some tasks cannot be defined well except by example. That is either recognizing the people. Some tasks are very difficult to define well, you cannot define it very well. So apart from like for example, if I want to recognize a person, I'll name by his or I'll call by his name, right? That is one way of recognizing. But you cannot do the same thing for all the examples. That's why some examples some examples are very complicated in such a way that there is no common way of specifying or defining it very well. The relationships and the correlations can be hidden within large amount of data. Machine learning or data may be able to find these relationships. So one important aspect is that the relationship between the different data items, right, is very important, and also correlations between the different data items. And these things are very difficult to identify in a large database. Let us take database of 1 terabyte. In a in a database of 1 terabyte, it's very difficult to differentiate, or it is very difficult to establish the relationship or the correlation between the different data. In that case, what you're doing is that machine learning or the data mining comes to helps, right? It is basically used to dig into the huge database, very large database, in terms of the gigabytes or the terabytes, and it will establish, or it will try to establish the relationship between the large data items. And human designers often produce machines that do not work as well as desired in the environment in which they are used. Right? Human designers often produce machines that do not work as well as desired in the environments in which they are used. Right? The human designers sometimes they design some machines which they are, these machines are not going to work in the designed environment properly. In under such circumstances, machine learning and comes into help. The amount of knowledge available about certain tasks might be too large for explicit decoding encoding by the human beings. For example, medical diagnostics. So you are generating in a digital revolution like this, so you are generating a huge quantity of data in terms of the gigabytes or in terms of the terabytes you are generating it. And if you start analyzing the data by by a human being, it takes years. It takes years to understand or analyze the data, right? Let us take for example for forensic reports. Forensic. Let us take for example, for each call you are making it, for each WhatsApp message you are sending it, for each message you are sending, everything will be recorded into the servers of the host, or in the WhatsApp. If you are sending a WhatsApp message, so and that message will go and go and stored in it will be stored into the servers, right? And if you send some malicious scripts or malicious kind of thing, or the inflammatory what you call it as pictures, or the messages someone has sent it, then if you start decoding it, who has sent this message, and what is the purpose, and from which WhatsApp group it has originated, and if you start analyzing it humanly, by a man, then it takes years. To avoid this one, what they have done is that they have used automated tools. It will be able to recognize the version of the data, or the version of the WhatsApp message from a particular group within a fraction of seconds, right? So that's why, so in a the amount of knowledge available about certain tasks might be too large for explicit encoding by the humans, right? You cannot what do you call it as you cannot encode the data, hugely collected data, by just making by a human being. Environment change over time, that is, if over environments may change over time, in that case machine learning can be very helpful. New knowledge about task is constantly being discovered by humans. It may be difficult to continuously redesign systems by hand, right? Environment changes over a time, in the sense that your hardware design changes, your software changes, and human behavior also changes, right? And in the such circumstances, you have to develop the new machines, or the new machine learning algorithms. And if at all not possible, then if you want to analyze it by using a human being, then it becomes a very difficult task. So for that reason, machine learning is an important aspect of the new world. So that is, the machine learning can be important because some tasks cannot be defined well, except by some example, right? By some examples, you cannot completely define the task very well, and you cannot uh, establish the relationship and the correlation between a huge data, because the data is so much large that uh, you cannot do it manually. That's why data mining and machine learning technique will dig into your large amount of data to explore the relationship and the correlation between the large amount of data. And human designers also produce machines that do not work as well as desired in the environments in which they are used. So humans will develop some machines or the designs, and these designs will not work as designed in the given environment. And some knowledge, the amount of knowledge available about certain task might be too large for explicit encoding by the human beings. You cannot encode it by human, because the amount of data what you have collected, it is very very huge. In such a scenario, you cannot do it manually, and the new knowledge about task is constantly being discovered by the humans. It may be difficult to continuously redesign systems by hand. You cannot, it's very difficult to redesign the systems by hand continuously. What are the areas of influence of the machine learning? So in which all the areas the machine learning has influenced it? The first area of the influence is statistics. Second one is the brain models. Third one is adaptive control theory, and psychology, artificial intelligence, and evolutionary models. In all these areas, the machine learning has influenced a lot. Let us take each one of them. In the case of the statistics, how best to use samples drawn from unknown probability distribution to help decide from which distribution some new sample is drawn, right? So statistics, in case of the statistics, we are just using some samples, and from this samples we'll draw the conclusion for the new samples. Next one is the brain models. Non-linear elements where with weighted inputs have been suggested as simple methods of the biological neurons. What you're doing is that we are just designing our own neural network in such a way that each neural network will be treated as one neuron, and from this one we are suggesting or we are equating these artificial neural networks with the biological neurons. And the next one is adaptive control theory. Adaptive control theory is how to deal with the controlling a process having unknown parameters that must be estimated during operation. Right? We don't know the parameter value, but we have to predict the estimation, or we have to estimate the value of that parameter during an operation. In such applications, we are just making use of the machine learning techniques. And psychology, how to model human performance on various learning tasks. So you different persons will have different learning experiences or the learning performances for a given task, and how each human being will what you call it as the perform for a given task. So that can be evaluated by using the machine learning. And artificial intelligence, how to write algorithms to acquire the knowledge humans are able to acquire at least as well as humans. How to write algorithms to acquire the knowledge humans are able to acquire at least as well as the humans. Artificial intelligence is nothing but it's a branch of the machine learning in which you're just trying to write the algorithms in such a way that the machines will get the knowledge, and this knowledge will be accumulated in such a way that it will try to take the decisions independently. That is called as the artificial intelligence. It learns something from its previous experience, and it will build a database. From this database, it will try to take the decision on its own. And evolutionary models, how to model certain aspects of biological evolution to improve the performance of computer programs. Right, you are just uh, trying to modulate or simulate what you call it as a biological evolution to improve the performance of the computer programs. You are just running some biological evolutions or simulating the biological evolutions to assess the performance of the or to improve the performance of the computer programs. These are the some areas of the influence of the machine learning. First one is statistics, and second one is the brain model. Third one is the adaptive control theory. Fourth one is the psychology, artificial intelligence, and evolutionary models. Next one, next one comes to the definition of a machine learning. What do you mean by a machine learning? A computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performs a task in T as measured by P improves with the experience. So machine learning, to define a machine learning, so what is said that a computer program is said to learn from experience E with respect to some class of task T, let us take it as a T, and performance measure P if its performance at task in T as measured by P improves with the experience E. That is, for a set of task called as a T with the performance P, if it is able to perform the task with the measured P, if it improves the experience, then we call it as the machine. Then the whole process we call it as the machine learning. I have given one example of multiplication, right? 4 by 3 is 12, right? and 5 by 4 it's 20, and 6 by 3 it is 18. That is my previous experience, right? That is my previous experience. Now what I will do is that if I am able to, if I'll give a new task called as 7 by 8, that is my new task. How much speed, in what speed you are able to tell the answer is called as your experience, or it is called as a performance. And if you're able to tell the answer correctly, then your experience will be your experience is going to be up, right? That is called as the machine learning. A computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance on task is in T as measured by P improves with the experience E, right? If the for the same kind of task, and if you are able to improve the performance as well as improve the experience, then we call it as the whole process we call it as the machine learning. And why to learn? Why the machine should learn, right? And the learning is used when the human expertise doesn't exist, right? If the human expertise cannot be able to perform the task, then you are just going to assign that, or we are going to teach the machine so that the same thing will be done by the machine itself. And humans are unable to explain their expertise, right? If the humans are unable to explain their expertise in such a situations, we're supposed to teach them, or we're supposed to teach the machine so that it is able to recognize the speech on its own. Solution changes in time. If the solution is going to change over a period of time, then in such a scenario the learning becomes inevitable. Solution needs to be adopted to a particular cases, like let us take user biometrics. And if the solution is to be adapted to a particular cases, in such a scenario the learning becomes the very essential. So under these circumstances the learning becomes very essential. That is human expertise. When the human expertise doesn't exist, in such a scenario the learning becomes inevitable part, or it becomes essential one. Humans are unable to explain their expertise. In such a scenario the learning becomes very essential, and solution changes in time or over a period of time. That is routing on a computer network. While routing a computer network, uh, the path taken by each and every packet will changes every seconds or every milliseconds, or even with the microseconds as well. So in such a scenario, the learning becomes very essential, because in which route or in which path the packets has to be transmitted, such decision has to be taken by the machine itself. So the learning becomes very essential for the machine. And solution needs to be adapted to a particular cases. If the solution has to be adapted to a particular cases, in such a scenario we have to teach the machine to learn something new. And here is one example of the learning problem, well posed learning problem we have it. Definition: a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with the experience E. That is what we have seen in the last two slides. What is that we have seen? The machine learning is nothing but computer program is said to learn from experience E. If the if the computer program is able to learn from the experience with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with the experience. All right. So in other words, to simply put it, you have knowledge of T task, uh, and if we are able to perform these T tasks with a performance P, right? That is what the thing, and with an experience code as E. And if a new task comes, and if how that new task is going to be performed or executed with a given performance, and how much expertise you will get it. That is called as a machine learning. To have a well-defined learning problem, three features need to be identified. The first one, the class of task, that is T. The class of task, that is called as T. The measure of performance to be improved, that is called as the P. And the source of experience, so E. So these three features has to be identified in a given learning problem, right? The first one is the class of task, also called as a T, and the measure of performance to be improved, that is called as a P, and the source of experience you're supposed to identify, that is called as a E. So these three features has to be identified in a learning problem. So let us look at one example of the learning problem called as a checkers game, right? What happens in a checkers game? Let us see here the game basics. Checkers is played by two players. Each player begins the game with 12 colored discs. These are all the discs you have it, right? Three, 12 discs you have it, right? One set of pieces is black and the other is red, right? There are totally for 12, what you call it as 12 color disc. One set of pieces is black and the other is the red. Each player places his or her pieces on the 12 dark squares closest to him or her, and black moves first, players then alternate moves, right? There are 12, what you call it as 12 disc you have it, and one set of pieces is black and the other red it is, and each player places his or her pieces on the 12 dark piece squares, and to him or her, black moves first and plays then alternate moves. The board consists of 64 squares, something like a chessboard. You have 64 squares alternating between 32 dark and 32 light squares, right? You have 32 dark square, red, sorry, black, and 32 light colors, right? It is positioned so that each player has a light square on the right side and the side corner closest to him or her. It is positioned so that each player has a light square on the right side corner closest to him or her, right? He has to place in such a way that he should have a right, sorry, what do you call it as light square on the right side corner closest to him or her. A player wins the game when the opponent cannot make a move. If the opponent player is unable to make a move based on the given rule, in most cases this is because all of the opponent's pieces have been captured, but it could also be because all of his pieces are blocked in. He cannot make a move based on the conditions what he has specified. Rules of the game: moves are allowed only on the dark squares, so pieces always move diagonally. Single pieces are always limited in the forward moves. Look at this one. So you can move only in this direction, only on the dark squares. You cannot move it on the light squares, right? You cannot move it on the light squares. That's fine. When the opponent exhausts, he has to move only in the dark circles, either the black one or the white one. He has to move only in the things. So rules of the game: moves are allowed only on the dark square, so the pieces are usually move diagonally. Single pieces are always limited to forward moves toward the opponent. That is, so one move will be done in the towards the forward directions. A piece making non-capturing move may move only one square, right? So what you do is that if you are moving in one direction, a non-capturing move, not involving a jump, may move only one square. If there is no capturing, he can move in only one square. A piece making a capturing move leaves over one of the opponent's pieces, landing in a straight diagonal line on the other side. If there is any jump, so he will leaps over the one of the opponent's pieces and lands diagonally on the other side. Only one piece may be captured in a single jump. However, multiple jumps are allowed during a single turn, right? Multiple jumps may be allowed during a single turn. When a piece is captured, it is removed from the board. When the piece is being captured, it can be moved from the board. If a player is able to make a capture, there is no option, the jump must be made. So if the player is able to capture, there is no other option but to jump it. If the more than one capture is available, the player is free to choose whichever he or she prefers. If more than one capture is available, he can do that, and it is left to the player. So these are the rules of the game. And when a piece reaches the furthest route from the player who controls that piece, it is crowned and becomes a king. When it reaches the furthest row from the player who controls that piece, he becomes the king. One of the pieces which had been captured is placed on top of the king so that it is twice as high as a single piece. It will be uh, placed on the top of a king so that it appears as a twice as high as a single piece. Kings are limited to moving diagonally but may move forth both forward and backward. They can be moved diagonally. That is, kings will be moved diagonally. Kings may combine jumps in several directions. They can combine in several directions, forward and backward, on the same turn. Right? They can be moved forward and backward. They can move back and forth in the same turn. Single pieces may shift direction diagonally during a multiple capture turn, but must always jump forward. If the king may move in several directions, that is back and forth, and also uh, but if the multiple capture is there, he must jump forward. That is what the rules of the game. So now we'll try to come back to my learning, that is well defined learning problem. So there are three rules we have it, right? So we have to identify the task, we have to identify the, or we have to measure the performance to be improved, and the source of experience. So we have to build that. So checkers problem is that task T, playing the checkers. This is my task what I have it, right? So this is the task what I have it. And the performance measure P, the percentage of gain won against the opponents. What is the percentage of games that is won against the opponents is the performance of a player. And the what is the training experience or the learning experience I had? Playing practice games against itself. Training, how he has got the experience, it is by playing against itself. Again, playing itself, from that one he has got the experience. This is what the problem definition, this is what the complete problem definition we have it. And these are the things, that is the task, performance, and the training experience. Task in the sense, what are the tasks we have it? Playing the checkers is my task. What is the performance? The percentage of games won against the opponents is called as the performance measure. And the training experience is playing practice games against itself. Playing, how we are going to practice the games by playing against itself is a experience we have got it. These are the three measures we have it: T, P, and E. Similarly, we can construct the learning experience or the learning well-defined learning problem for the different problem definitions. Next one is a handwriting recognition learning problem. The first one is the task T, recognizing and classifying handwritten words within the images, right? How the different handwritten words will be written within an images that has to be recognized and it has to be classified. And what is the percentage? And it is the percentage of words that has been correctly classified. So how much percentage of uh, how much percentage you have classified it correctly is called as the performance measure. And the training experience, a database of handwritten words with the given classifications. We have a classifications, and based on this classification what you are doing is that you are choosing a word, new word, and I have to decide to which group or to which classification uh, that handwritten word has to be kept it. Okay, and this is what is called as the handwriting recognition learning problem. So task D, recognizing and classifying handwritten words within the images. Using this one, you are able to classify and recognize handwritten words within a given images. And the performance measure P, percentage of words correctly classified. How much percentage of words you are going to classify it correctly? For that one, you should have a training experience, and this training experience has come from the it's you are maintaining a database of handwritten words with a given classification. And there is one more learning problem we have it. The first one is a robot driving learning problem. And again, we have to identify three tasks. First one is a T, second one is a P, and third one is a E. Task T, driving on public four-lane highways using vision sensors. This is this is the task of a robot driving. What it is going to do is that it's going to drive on a public four-lane highway. Your robot is going to run it on a or it's going to drive it on a public four-lane highways. Performance measure, average distance traveled before an error. That is very important. Before making an error or before hitting into an obstacle, before hitting into an person or an object, whatever it may be, how much distance it has covered. Let us take your robot has started now, and if it is able to travel 1 kilometer now without any error or without making an error, then your performance is that robot has driven 1 kilometer perfectly. And if the same robot in the next trial, if it is able to hit an object, or if it is able to make an error within a 500 meter travel itself, then we say that the performance is what we call it as 500 meters, right? Something like this. Average distance traveled before an error, right? Before making an error, how much distance the robot has driven or it is driven, it is called as a performance measure. And training experience, a sequence of images and steering commands recorded while observing a human driver, right? So this we have installed the human sensors in a robot. So this human robot also contains images and steering commands recorded while observing a human driver. It contains all the database of the images and the steering commands that is able to monitor the or that is able to observe the human driver. These are the three observations we are making it. First one is the T, that is a task, which is driving on public four-lane highways using a UV vision sensors. It is able to drive it on a four-lane vision sensors. And performance measure, average distance traveled before an error has occurred. And training experience E, a sequence of images and steering commands recorded while observing a human driver. So this is what you call it as a robot driving learning problem.